All right, so we're still running with the same problem from the book, problem number 4 from the back of the chapter. We just ran the full ANOVA, and the decision was to reject the null hypothesis with 3 treatment conditions, meaning that we need to do a post hoc to better understand our results. So again, Tukey's is the only kind that I'm teaching you how to do, so it's the only kind we can do. We never have to worry about the sample size restrictions with the repeated measure test. Remember, Tukey says all the groups have to have, all the treatment conditions have to have the same number of scores, equal sample sizes. Well, it's only one sample here running through 3 conditions, so that will always be checked off. So we can see the formula is mostly the same. Our honestly significant difference is Q, which we look up, remember, times the square root of, and here's the change. Last chapter, this said mean squares within treatments, because that's what we were using for error, divided by sample size. Now, of course, it says Q times the square root of mean squares for error, because that's what we're using for error. So to get our Q value, just like usual, we've got to look it up in our Q table, so it's behind the F's. So table B.5, across the top, number of treatments. We had 3 treatment conditions, so over to 3. Down the side, degrees of freedom for the error term, that was 8. So over to 3, down to 8. And we see again a pair of numbers for 0.05 and 0.01. We ran the ANOVA at 0.05. So again, we're going to run the post hoc at 0.05. So we want the light face type. And we can see that says 4.04. So Q equals 4.04. Mean squares for our error term was 1.25. And the number of scores in each condition, of course, was 5. So those are the values we have to work with. So remember, 1.25 divided by 5 first, then square root that value, then multiply that value by 4.04. When you do all of that, what you're going to end up with is, again, go calculate it, pause the video, go calculate it. The end result for that is an HSD of 2.02. So again, what does this tell us? It tells us that the sample means need to be at least 2.20 points apart or more, just over a couple points apart, to be significantly different from each other. Well, the problem also set us up with all the sample means. Sample mean for the first group was 1 point. The sample mean for the second treatment condition, same sample, but second treatment condition, was 5 points. And the sample mean for the third treatment condition was 6 points. Those are the same numbers we had the last time we did this as a coincidence. So now what do we have to do? Again, make every single comparison that can be made. 3 treatment conditions, 3 sample means there's 3 comparisons to make. Again, if there were 4 groups, there'd be more comparisons to make. If there were 5 groups, there'd be even more. So we need to be very methodical. Again, we're just looking for absolute distance between them. Positive, negative doesn't matter. We're just looking for absolute distance. So sample mean 1 compared to sample mean 2. Sample mean 1 is 5 points. Sample mean 1 is 1 point. Sample mean 2 is 5 points. So they are 4 points apart. They only have to be just over 2 points apart to be significantly different. So group 1 and 2 are significantly different from each other. Group 1 compared to group 3. Well, again, group 1, treatment condition 1 has a mean of 1 point. Treatment condition 3 has a mean of 6 points. They are 5 points apart. So groups 1 and 3 are significantly different from each other. And then lastly, compare groups 2 to 3. 5 points compared to 6 points, there's only 1 point of difference. So these 2 groups are not significantly different from each other. So just like last time, if your decision in the ANOVA was to reject the null, there has to be a difference in here somewhere, or there's a mistake in one side or the other side, or maybe both. So that is our post hoc test, again, our Tukey's test for our repeated measures ANOVA, almost exactly the same as last chapter. So we've got just a little bit left to do in this chapter. Really, the main thing we have left to do is we're going to start discussing what do we do if we have more than 2 factors. And as I promised you, we're not going to calculate it. You can look at it in the book. It'll show you how, but you thank me later. Not with calculators. That's computer work right there. But we need the vocabulary because multiple factor ANOVAs are one of the most common research designs across the sciences. So it's really important to be able to digest it, to understand what they're trying to communicate to you. So we'll take care of all of that in the next video.